Okay, so we're going to be talking about safe as in Gnosis Safe and the privacy aspects of it. And first of all, like I represent 1KX, which is a VC fund, and the question is, sometimes I'm getting this, why build as a VC? And Lucas, the founder of Gnosis Safe, basically said this, that we are kind of the ultimate cypherpunk VC out there. And seriously, we're interested in just enhancing the ecosystem and just contributing to the space. And this gives us more opportunities as well, like for investments. But this is not a commercial product. This is free, open source stuff, just trying to do something good for the community. So what is it all about? When multiple people need to sign transactions, we basically have two options. One is MPC, the other is multisig. And sometimes in the past you could hear that, when do you choose MPC? When, MPC is compatible with multiple chains and there is no on-chain trace because it all happens off-chain and there's privacy. And in multisig, well, there is on-chain trace and basically everything is public, everything is transparent, everybody can see what happened and who signed which transactions. And this is kind of a limiting use case. But on the other hand, multisigs are much preferred in practice because Gnosis Safe is the most used multisig, over 100 billion TVL. Solidity code has been verified. It's like the textbook of, if you want to learn all the solidity tricks, you just need to read the smart contract code of Safe. And it's like when you ask people who actually work with Solidity a lot, what is the best code to read, they would point to Safe. And the use cases are not limited to just storing assets for Safe. It's very often used essentially for governance, right? When you have a committee and the committee needs to vote for something, and then this happens very often through Gnosis Safe. In practice, for example, L2 networks, when they need to release a new version of their network, it often comes through an L1 transaction. And for decentralization reasons, you must not upgrade your L2 network just by running some command somewhere. It goes through an L1 transaction that has to be signed by multisig, and this happens through various security committees that have to be in place. And for various reasons, these security committees need to be public, the membership of the security committees, because you need to see that there are real people there. But who exactly signs what out of those security committees, you don't want people to know. And this is precisely what we solve with ZK Safe. So what we do currently is we make sure that, how do multisigs work? You basically collect signatures, and when there are enough of signatures collected, you can send it, Gnosis Safe will verify it and execute the transaction. We make a small modification where somebody has to collect all the signatures and create a proof that they have seen and verified all of these signatures. Now, you send your transaction, the desired transaction, along with the proof to a ZK Safe module, which does the verification, and then we execute this transaction. So it's a very simple scheme, which for some reason was kind of hard to build. So the UX flow is actually a little bit different because how do you normally, does anybody use multisigs here? Okay, nice, great crowd. So you probably use Gnosis Safe, right? What you do is you just have UI where you basically sign one transaction and then the other signers get a notification that there is a transaction to sign and so on. The problem with this is that this is a centralized component of Gnosis Safe, which is kind of fine if you are in the open, right? But if you want to actually hide the fact that signatures are being collected, this doesn't work, because all of the signatures collected during the process are stored in the Safe backends that everyone in the world can read them. So it's not only on chain, but it's also on this infrastructure. So we had to a little bit modify the flow so that you basically are responsible for collecting signatures. And the way we do this in the UI, we basically embed them in URLs, and people need to send to each other messages using instant messaging or whatever means they have to exchange all the signatures, collect them together, and then somebody who, when all the signatures are collected, needs to click the button to generate the proof. And then we basically can send the transaction together with the proof. So, and because of that, we also had to modify the UI. We basically built another alternative UI for Gnosis Safe, which actually does not have a backend. And later we realized, okay, but actually it's an interesting thing because ZK or not ZK, there is a need for backendless UI because there are many chains that do not have support for official safe UI. So basically, we also use it for some chains that have safe contracts deployed, but they do not have official support for UI. You just fire up a browser, you configure your RPC node where you have your weird network, and there are many, many weird networks out there. You have the weird network with safe contracts, and it works already. So, and then you can use ZK or not use, but you kind of have safe support. And BuildBear is also an interesting tool where you basically can have as many test nets as you want for any network. So basically it forks networks in a cloud environment. And but like when you clone a network, when you fork a network, you don't have the UI support, but with this tool you can have it. The more technical part here, and I have 3 minutes, maybe I'll spend 1 minute here. I mean, I think it's pretty straightforward. What do you need to verify a signature? Well, you need to see the threshold of this safe, you need to see the transaction hash, you need to see the list of owners, and then the private information which you don't want to expose is actually who signed and their signatures. So these private inputs go into the prover from the person or agent or whatever who collected all the signatures. And the logic of this proving is exactly as in Gnosis Safe Solidity code that verifies the provers. And Aztec Noir has been pretty good for this. And it's quite interesting that Aztec Noir ended up being the only single solution here, surprisingly, because it's the only thing that supports CCDSA verification and at the same time has an efficient WASM proving, because all the proving done in the browser. There is no server, there is no component. So the signatures that you are collecting are never sent anywhere. It's like all local in your browser. And to this day, it is kind of the only way to build this, paradoxically. I was told by Risk Zero that probably you can do the same in browser now, but like a few months ago you couldn't do this, so maybe we could try that. And we have more web assembly proving coming with a company called Ligero soon. But it is what it is. Right now, Aztec Noir ended up the only choice. So what we plan to do as well is we only hide right now who from the group has signed a transaction. We don't hide the group membership like the owners themselves. And the reason for that is that in most cases, you actually want people to see that this safe has a reasonable amount of owners, because otherwise, if you hide that, then you don't even know if there is more than one person controlling it, like you cannot distinguish that. But there are use cases for that as well, and we've actually been told, okay, we would like to use this, but we also need to hide the owners. This is kind of semi-implemented, it's work in progress, but the circuits are implemented, not yet audited, so we're going to be working on this and also release a version that also hides everything. And we're not the only ones who are interested in this problem. There is also a project called DarkSafe, which does some interesting math. You can look it up. Does this in a funny way. And yeah, these are the URLs and the contacts if you want to learn more and if you want to use it. And I think that's it from me. I don't know if we have a minute for questions.
Thank you, Valeriy. Questions from the room? Yep.
I was just wondering, if you have these proofs in the URLs, are there any issues with URL lengths and the proof sizes?
So you're worried that the exchanging URLs will kind of expose something, or?
As in, I'm sure there's like a limit on how long a URL can be.
Oh, yes. We put signatures, not the proofs in the URL.
Okay.
And in the UI, basically, it looks like when you have everything collected, we use just browser or local storage for that. And then you just copy paste the proof. So it does not go into the URL. It's like it's displayed on the web page in a box, right? That's a good question. I mean, there are other ways of doing this, which is just something that's easy to copy paste, basically.
Yep.
Do I get this correctly, that the whole transport layer or communication layer is not something you're solving? This is just then you take whatever,
Absolutely.
Chat messages
Absolutely.
or whatever.
It's just, it's up to the group that does this. And usually they will have some signal or telegram. And I mean, if they're happy with the privacy of communication among them, then that's okay, right? So.
Okay. Thank you very much, Valeriy.